Okay, this video is just talking about some notation issues that I want you to be careful about when you do your test. A lot of it has to do with simplification and parentheses. Okay, so let's just start with trig functions. So if you have the sine of x, that's pretty obvious that that is, you're taking the sine of x. But if I did the sine of x squared plus 3, to make sure that I know that I'm not doing this, just the sine of x squared, I want to make sure that I put that in parentheses. So don't ever leave the parentheses off. This might be overkill in saying you always use parentheses. I'm not going to take off for putting an extra set of parentheses here because it's always obvious what the argument of the sine function is. So unless it's just the sine or cosine of x, you want to put parentheses in there. So if I were to give you a function, the sine of 5x squared plus 4x, and I asked you to find the derivative of that, you'd use the chain rule, and the answer would be the cosine of 5x squared plus 4x. And then you would take the derivative of what's inside. So if you did that, you'd have 10x plus 4. But again, you need to have parentheses, whether this is in the beginning or the end. Because if I didn't have the parentheses, I'd just multiply the cosine by 10x. I wouldn't multiply the cosine by 4. So you have to have that to know that you're multiplying the entire quantity. Another thing about when you have a derivative where you have a trig function and a polynomial, you want to always put your final answer such that the polynomial is in front. And again, if I didn't put my parentheses in here, which I'm going to not do at this point, but that's incorrect. So that would be incorrect. You got to make sure that you have that. And if you think about it, if this were switched and this were the cosine and you had negative the sine, you'd have to make sure the negative is out in front of the entire parentheses. If I just put negative without the parentheses, there would be two errors. One is I wouldn't know that I'm multiplying this whole thing times the cosine, and I would only apply the negative sign to the first term. Now another place that you might end up having questions about parentheses is if I had something like f of x is equal to 5 divided by x to the 5th plus 3x squared to the 3rd power. So if I would need to rewrite this before I took the derivative. So I'd move this term to the numerator. And again, if I didn't put the parentheses out here, I wouldn't know that I'm going to be raising the whole thing to the negative 3 power. So again, in the first case, I need the parentheses because I'm showing that I'm cubing this whole thing here. But when I move it to the numerator, the same thing has to happen. So if I took the derivative of this, now that I've rewritten it, again using the chain rule, and I'm not writing out the full chain rule here, so I want you to do that during the test. I'm just doing this because I'm taking the shortcut because I'm talking about notation. So what you would have is you would have 5, and then you take the derivative, or you take this exponent, and then you would leave the argument of the thing that you are cubing the same. You'd reduce the exponent by 1, and then you'd multiply by the derivative of what's in here, 5x to the 4th plus 6x. Again, notice I put the parentheses here so that I know I'm multiplying the whole thing. Now, one thing that I did wrong on purpose here is I didn't put a parentheses here. Now, I've shown these little dots which represent multiplication, but really the better way of doing it here would be to put a -3 in parentheses like that, so that I know I'm multiplying 5 times -3. I'm not subtracting. I'm not taking 5 and subtracting 3. It also allows me to write this without little dots in there. Now I've put a dot here, which I don't really need because I have the parentheses to kind of keep that all straight. Now, to simplifying this, that's another thing, is you always want to have positive exponents finally. So there's a couple things that I would do to put this in the right order. One is I'd multiply any constants together. And if I have a negative times a negative, I'd have a positive. In this case, I have a positive times a negative, so I'm going to have -15. So that's in the numerator. This is also in the numerator because there's no negative exponents. Again, I'm going to put parentheses here so that I know I'm multiplying -15 times this whole thing. And then I would move this part to the denominator. And again, I need to keep the parentheses to show that I'm raising the whole thing to the 4th power. So it's better to be safe by using, I guess, in English you always think, well, maybe it's safe to use commas, and they don't like that, but in math, a lot of times it's better to use parentheses. Okay, there's a couple of simplification issues. If you end up with a derivative that is going to be 2x squared over 4 times the quantity 3x, and this may not make sense from a math standpoint, but we're just talking about notation, something like this. Okay, so let's say you had an answer that looked like that. For one thing, you want to look for if there's a common factor here. So I would want you to simplify that if the constants allow you to simplify it. So you can divide both these by 2. Now there's cases where people try to simplify too much and they use the wrong rules. So this might be a case, it might be like, oh, well, I'm going to go ahead and multiply this 2 out. And somebody would write this out. And they would make like 6x cubed plus 8 things squared. That's not going to work, okay? Because you can't just, unless this is to the 1st power, then you can't distribute this number simply. So sometimes be careful about going too crazy with simplifications, because a lot of times you'll make a mistake. Another example would be if you had x over 3x squared plus 7, and some people would say, oh, I've got an x here and I got an x there, so that's got to be equal. I can cancel that out and I get 3x plus 7. Okay, not good. Anytime you simplify, you've got to have the same quantity in every term. Here, because this has been factored, this is outside the parentheses, then 2 is multiplied by the whole thing. So we know that, or over up here, this whole thing's times 4. There's a whole thing, the whole numerator is multiplied by 2. So be careful about doing that. Another example where you could simplify incorrectly is kind of here. And if you, well, let me give you another example. So let's say you have 2x squared plus 1 over 2 times the quantity x squared plus 4 to the 5th power. So again, I have to divide both of these terms by 2. Well, they're not both divisible by 2. So this would be incorrect. This is wrong. Because you say, oh, I'll cancel out the 2's. Well, that's true. You did do that, but it's wrong. You'd have to have, if you wanted to do that, this would have to be also a 2, so that you divide each one of these by that common factor. Okay. I'm just looking through the test to see if there's anything else that I want to talk about. Yeah, I guess the final thing that I can think of right now, and if I think of anything else, I will put it in here, but sometimes people end up with two negatives. They'll have a negative in the numerator and a negative in the denominator. Now in this case, what you might do is you would factor out a negative. So this plus 1 would become negative. And in that case, because I'm taking the negative of this entire denominator, then I can simplify it. So that you don't want to leave two negatives here, especially in this situation. I mean, this is probably, I wouldn't knock you as bad for that, but if there's obviously two negative constants, you want to convert that to a positive number. So that's what we would do here. So that's correct. Okay, don't leave two negatives in your answer. And we've talked about square roots. So if you have a function, let's say it's equal to the square root of 5x cubed plus 7x squared, and I wanted to do the derivative. So what you do is you'd rewrite the original equation as a fractional exponent. Then you'd use, once you've done that, then you can use the power rule. Now in this case, you'd have to use the chain rule and the power rule. So what you'd end up with is 1/2 the exponent here. You leave the argument the same in that parenthesis. You'd subtract 1 from the exponent. But then you have to multiply by the derivative of what's in here, u prime of x. So you'd have 15x squared plus 14x. Notice again I put parentheses here so that I knew I was multiplying this whole thing. Now, of course, I don't like negative exponents, so I'm going to move that to the denominator. I can leave this expression here in the numerator, and because I'm going to put this 2 in the denominator, I don't really need the parentheses here. If you did put parentheses, I wouldn't mark off for it, but you don't need them. The 2 comes down, it's already in the denominator, and then you'd move this one to the denominator, but you change the sign to positive 1/2. And so this is the one case where I want you to rewrite a fractional exponent as square root. So this then would become the square root of 5x cubed plus 7x squared. If this were a third or a 3/2 or whatever, just leave it as a fractional exponent. One of the reasons is, in your calculator, you can do square roots, but usually if it's something other than a square root, some other root, or especially something that's a improper fraction greater than 1, or just not a simple fraction, then you're going to have to use the fractional exponent anyway to evaluate the function. Okay, so one more point. And so let's say you had a function that's a product of two parts. And let's say it's going to be equal to x cubed times the square root of 9 minus x squared. So this is a product rule example. So let's change that to h of x, just because then I can call part of it f of x. So you'd have f of x is x cubed, and g of x is equal to the square root of 9 minus x squared. And so we can rewrite g of x as 9 minus x squared to the 1/2 power. And so now we can take the derivative. So the derivative of this would be 3x squared, and the derivative of this would be So you'd have to use the chain rule. So you'd have, you get 1/2 the exponent times 9 minus x squared to the negative 1/2 power times the derivative here, which would be negative 2x. So again, what I want you to, if you had to do this, I want you to write it out. So I guess I should show you, even though we're just talking about notation. But you'd let g of u equal the square root of u. You'd let u of x equal 9 minus x squared. So you'd rewrite g of u as u to the 1/2 power, and u of x doesn't change. So now we take the derivative. So you get 1/2 u to the minus 1/2 power. And here u prime of x is negative 2x. Okay, so you can see how g prime of x is going to be 1/2 u to the minus 1/2 power times u prime of x. Now, again, notice I put the parentheses here. And I don't know why I put a minus sign there, so let's get rid of that. So you get 1/2 u to the 1/2, negative 1/2 times that. And so if I multiply this out, I'll get negative x times u to the negative 1/2, which is the same as negative x divided by square root of u, which is 9 minus x squared. So you can see if I clean this up, I get the same thing here. I get negative x over the square root of 9 minus x squared. Okay, so that's f prime of x, g prime of x. So if I want to find the derivative of this product, it's f of x times g prime of x plus g of x times f prime of x. First times the derivative of the second plus the second times the derivative of the first. So now this is the key part. So when I plug these in, I'll have x cubed, and I don't have to put a parenthesis, but I would definitely put a parenthesis for the next part. So notice how the negative sign is going to be inside the parentheses. So I've got x cubed times this parenthesis. If I didn't have the parenthesis here, I'd think I was subtracting this, not multiplying it. So to make sure you know that you're multiplying it, then you need to multiplying this negative quantity. Now if this were a positive quantity, then it wouldn't matter. I may not necessarily need the parentheses because I know it's multiplication, but because of the negative sign, I can get confused whether I'm multiplying by a negative number or whether I'm subtracting it. And g of x is going to be, I'm just going to use g of x before it's written as before I've written it as a fractional exponent. So I've got the square root of g square root of 9 minus x squared. Now, do we need to put this in parentheses? Not necessarily, because if the square root is over the entire thing, then I know it's together. And then I would multiply by 3x squared. So, there might be some confusion of where this square root ends, so I might put a parenthesis here just to be clear about that. So instead of having the square root of 9 minus x squared, 3x squared, I put this extra parenthesis in here. Now ultimately I would want to simplify everything here. So I wouldn't want to leave the negative sign inside the parenthesis, and I wouldn't want to leave the 3 out here. So the way you would reorder this is, one is you could multiply x cubed times x. So, but first you'd put the negative out front. The sign always goes out front. Okay, the numerator is x to the 4th. The denominator is the square root of 9 minus x squared. Over here, I'd have 3 x squared times the square root of 9 minus x squared. So the square root term is last because obviously I know where it ends because it ends at the end of the equation. And I wouldn't need to put x squared in parentheses because obviously I'm squaring x. I'm not squaring 3x. You know, if I was squaring 3x, I'd need to put parentheses around the 3x. So that's, I guess that's another one last point is, you know, there's a difference between this does not equal 3x quantity squared. So if you have something you're squaring that's a quantity, you can't just put the exponent there and assume that it applies to both of these. The only way that you know it applies to both of them is by putting the parentheses. Okay, so hopefully I did all that right. But the key, you know, as far as the notation is concerned, I think that's what's important. Now you may say, okay, do I need to combine these two into a single fraction? And actually, I may ask you to do that. So let's just, what you would probably want to do here is you could factor out 1 over the square root of 9 minus x squared. And what that would leave is just x to the 4th here. And the second term, don't forget your negative sign, so I'm going to put the negative here. And then you have plus 3x squared. So when you factor this out, you are, and I'm factoring it out in the denominator, so this would actually become the quantity 9 minus x squared. Because what I'm doing is dividing by this, and so I'd have to multiply by this to balance it out. So if I divide by this and multiply by this, then I end up, when I divide and multiply by the same thing, here it's going to cancel out, and it comes out as a term in the front. And at that point, you could simplify inside the square brackets there. So you'd have you can multiply this out now because it's not a square root anymore. So 3 times 9 is 27. So I have 27x squared. 27x squared. Yep. Fix that. (27x squared). And then I have negative 3x to the 4th minus 1, so I'd have minus 4x to the 4th. So that's an example of simplification. Notice I put the positive term first, even though this is x to the 4th. A lot of times you put the positive term first